Welcome back, everybody. I hope you all had a good lunch or whatever meal your time zone dictates. We're going to start our next session, The Places We Go, implementation projects around the world. So these are going to be different scales, different contexts, different approaches. Very excited to hear what people have to share with us. If you have questions for the presenters as they're presenting, please put that in the chat. Write the name of the presenter, colon, and then the question you want to ask. So we have several folks coming up here. The first one is Julien Saludas from TOOPI Organics. Julien is the R&D director of TOOPI Organics, and he's an agronomist who graduated from the Engineering School of Agronomy in Toulouse. So I'll make you a co-host here, and you'll be able to share your screen, I believe.
So thank you for all. So let me introduce you to TOOPI, so our French startup, which is our transform agriculture with urine. So the TOOPI startup has been launched in February 2019 by Michael and Pierre. So our mission is to create a green, viable model for crop biofertilization and bioprotection, thanks to our quite simple technology to upcycling human urine to microbial biosolutions. And so then to drive an ecological and agricultural revolution. So we are only 2 years now, and so we have did some milestones. First of all, we already secured 3 million liters of urine, especially in France. We've built a semi-industrial plant of 300,000 liters a year of capacity. So in Bordeaux, in our earthquake, sorry. And so we have also raised 5.5 million euros since the very beginning. You have also 3 patents filed and one under PCT procedure, and we have also a product under market approval in France. So now let's talk about the team. So we are 24 employees, and so we obviously have the 2 founders, so Michael Russ and Pierre Huguet. So I would say Michael is a self-made entrepreneur, and Pierre Huguet is got a PhD in soil ecotoxicology. Also, we have a steering committee with 3 people. First of all, so Alexandra Carpentier, who is the CEO, with lots of experience in business development, strategy, public affairs, and also experience in the ministry in France. René Besnage, who is the CFO, with lots of experience as well in the finance and human resources management. And myself, so the R&D director, Julien, with experience in agribusiness, especially in the crop protections and also a French agricultural cooperative. Now, when we focus on the R&D department, we have 4 agronomists, 2 PhD in microbiology and the fermentative process, and also 3 lab technicians. So now let's talk about the solution and the model. So in fact, we use human urine to upcycle it into agricultural bioproducts. So first we collect urine as a raw material for free. So thanks to our uriners, we'll discuss this point later on. We transform it locally, thanks to a patented process that use, in fact, urine as a growing medium to grow microorganisms of agronomic interest. And then we sell the final bioproducts, so either biostimulants or biocontrol, sorry, which are non-polluting and also cheaper than the current bioproducts. So it's in fact in France the first real, I would say, agricultural valorization of urine as a real viable farming products. Sorry. Now let's talk about the model. So obviously this is ensured thanks to I would say circular model. So we collect locally, and then in the vicinity of the collections we build transform units, and we distribute the final products thanks to the already existing network of distribution. So in France, it's called farming cooperative, so agricultural cooperative. And so we build a kind of joint venture with them, and then we in fact the cooperative produce the final products in cooperation with TOOPI as a JV model, and so they produce themselves the products for their members. Okay, so this model is really replicable. It doesn't need a lot of capex and very little infrastructure to do it. And so we can easily replicate this model in the different territories in France, but also abroad. Now the value proposition. So in fact, the first product is a microbial biostimulant called BacTP. So it's in fact the first urine-based product so in France, but also I know abroad, you need market approval to be on the market. So it's an ongoing procedure in ANSES, which is the French regulatory affairs in France. We already demonstrated the efficacy of the products, the innocuity, the consistency, and the efficacy. Okay, so the dossier is under assessment, and so we expect the final decision in the first quarter of 2022. So the compositions, the uses and claims. So it's in fact the final product is a liquid formulation. In fact, it's the processed urine used as a growing medium and as a carrier as well, with a strains of specific strains of Lactobacillus paracasei. The final product is used by the farmers in furrows by spray application, at sowing or at pre-emergent stage on cereals, vineyards, vegetables, lawns, garden, flowers. So roughly all the plants, I would say. And so the claims now it's based on phosphorus solubilizations and also plant growth promoting rhizobacteria, because this bacteria has, I would say, this abilities to solubilize phosphorus. In the right part of the screens, you have some, I would say, trials. So, sorry, because it's in French, but you have some, I would say, claims that are demonstrated thanks to these results. So for flowers, you can see, I would say, the rhizogenesis, which is improved by the uses of the product, despite the fact that we have decreased, I would say, the fertilization by 25%. And then at the bottom, you have some results on maize, which is also good, because we show that we could maintain the same yield at the end in irrigated maize in the southwest of France by decreasing the uses of APP, which is a very well-known, I would say, fertilizers used in maize, by using our product with a rate of 25 liters per hectare. Sorry. So the other value, which is very key, is the fact that our solution is cheaper than the current biosolutions, because you all know, I think, that you have lots of biosolutions or biocontrols and biostimulants on the market already. But in fact, so in the left part of the slide, you can see some biostimulants prices per liter with different, I will say, competitors, BASF, Coopert, L'Allemand, Syngenta, Yara, okay? But we have, I would say, two main advantages in terms of prices, because in fact, we use urine as a growing medium, which is 8 times cheaper than industrial ones, which is very, very important. And also because we use a kind of frugal low capex fermentative process, which is not the case for the other competitors. So it gives us a lot of advantage in terms of cost of products, and also obviously the best value for money for the products for the farmers. And on the right part, you have other technologies that you already discussed, and I'm sure that you will discuss it later on. And obviously our process generate no waste, because we don't extract anything. We don't extract minerals. We don't extract the microbial biomass. And again, this is clearly an inexpensive process compared to the other technologies like struvite extraction, ammonia stripping process, and so on. And so obviously, it doesn't need any, I would say, expensive additives, and also lots of energy to do it, because it's a simple fermentation. Now the next steps in terms of bioproducts and the developments. So we now focus on biological nitrogen fixation, so the BNF, and also biocontrols, because this kind of developments use the very same process in terms of fermentations. So first of all, the BNF, and especially in France and Europe, to in fact, I will say, help the agroecological soybean development and the proteic autonomy, and so in the resilience in Europe. And then the plant biocontrol with a focus on fungicides and insecticides. So you have, again, you have on the bottom, you have two pictures. So on the left part, you have, I I would say, the first demonstration of the successful field trial for soybean urine-based inoculant of Bradyrhizobium diazoepiciens on soybean. We showed that it was possible to use urine as a growing medium to produce this kind of inoculant with the pretty same results as the, I would say, current inoculant on the market. And on the right part, you have some, I would say, first promising results in terms of biocontrol by testing some antagonisms against Botrytis cinerea on tomatoes. So again, we show that at the lab, I would say in planta, we have the pretty same results as the other biocontrol products on the market. In this case, it was Rhapsody, which is a very well-known biocontrol used and sold by Bayer. Okay. And so now, last stage, urine collection. So because I didn't explain this, we use, in fact, waterless urinals to collect urine as a growing medium. So obviously, we don't want to have water, obviously. So we have lots of partnerships in France, but also in Belgium and also in other countries in Europe, thanks to toilet rental companies, but also some buildings and gas stations. So we have partnerships with Vinci, for instance, in France, and we had the capacity to collect roughly, as I already explained to you, 3 million liters of urine to do, I would say, our first prediction. Okay, thanks for your attention.
So thanks for sharing that with us. Our next presenter is Jess Laporte. Title is Large-Scale Production of Urine Diverters for a Household. Jess Laporte is a member of the research and innovation team at Soil. Originally from Vermont, Jess has worked at the intersection of public health and social acceptance in Haiti since 2014, from clean water to women's health in the garment industry, and eventually ecological sanitation with Soil. Jess also holds a variety of roles in community-based grassroots networks for Black, Indigenous, and other people of color in Vermont, with Conbit Soleil Leve in Haiti. So please share your screen and unmute yourself, and you have the floor.
Hi all, my name is Jess Laporte. I use she, her pronouns, and I'm patching in from the Waterbury area of Vermont, but I was very recently with our team in Haiti, which brought me a lot of excitement and joy. And I'm going to talk about large-scale production of urine diverters, but kind of more broadly, urine diverting toilets, particularly in the context of household container-based sanitation in Haiti, which I think, there's all different kinds of folks on the line today, but I think that it presents some unique constraints and challenges. So to start, just for those who aren't familiar with Soil, we're a research and development organization operating in Haiti, and we've been working in ecological sanitation since 2006. And after, as many people know, we got involved in earthquake relief after the 2010 earthquake. But what we also transitioned to shortly after was looking at how to develop a household toilets system. And we developed this ecological sanitation system called Ecolakai. And it works, it's highly mobile, it's installed in folks' home, and it does operate with a service. So we do weekly servicing currently to exchange full buckets with our carbon cover material. And the full kind of cycle for us is both through collection from the households to waste treatment, which is really important in Haiti because only about 1% of human waste is treated in the country, and we treat basically all of that. And all of our waste is transformed into high-grade agricultural compost. One thing to note, since you're a lot of urine people here, are the urine in the toilets is managed mostly by the households in kind of a socially acceptable way due to common use of chamber pots. So urine is discarded kind of in the similar way to those overnight options. So looking a little bit more on the technical side, this is our current toilet. We use a handmade concrete base as the main structure. It's very durable. They typically last about 5 years. And then there's all these wonderful attachments or additions. Our toilet seat, we use currently a cut funnel for urine diversion. We use a 5-gallon plastic container for capturing feces, and the urine is diverted into 1-gallon plastic jug. And I would just include in here, our most commonly replaced part is the toilet seat, which is something that we buy locally or sometimes have to import. And as we've been looking at improving our service, improving customer satisfaction, which is a main driver for a lot of our technological exploration, we really wanted to improve the urine capturing, because the cut funnel, as you can kind of see in this image, only covers so much. And in our journey to do this, durability has become something that's really important when we're testing new materials and new models, making sure that they're going to hold up to use. These are used in households. Our average household size from a recent survey was over 5 household members, and we know that there could be even more using the toilet. Of course, easy to clean. We want something that's attractive, and we're trying to grow towards mass producing these, and would love to do that in Haiti. In our trajectory of looking at urine diversion with our toilets, we have kind of a short-term focus, which is about finding a urine diverter that fits our current model, and a long-term goal, which many of our Container-Based Sanitation Alliance members are using, are kind of these designed, mass-produced toilets, usually plastic-based, that have an improved urine diverter as a part of them. So to kind of start our journey, I wanted to share basically where we started as a household service. So in our 2012 pilot, which was really like market research, we had these wooden toilets built covered with Formica. And the reason why I start here is because they started with kind of a pre-made out of package option for a urine diverter. And unfortunately, some of the challenges are that urine diverter didn't hold up. It also was pretty expensive, $70 a pop. And something that was just mentioned when I hopped on the line before this was this idea of matching, your customer's ability to pay and what the market is looking for, and what is economically feasible. And that definitely is not. Another main thing is that we operate in a lot of flood-prone areas. So the wood did not withstand kind of frequent flooding in some of those areas in folks' homes. So since 2012, we've kind of been on a journey towards a more durable toilet. And that's where the concrete base that I mentioned before comes from. This is just kind of a side cutout to show you how things fit together in there, since I can't demonstrate everything from here. And it definitely took a while to get where we are today. Many much heavier concrete models. We had other wooden boxes, and we had experimented with some other urine diverters, both really trying to recreate what was available on the market, but it might not fit our current toilet design. We also had a brief foray into a metal toilet, which obviously eroded very quickly. So it's been quite a journey just to where we are today of standardizing our toilet. And something that we began in about 2016, 2017 was, how do we begin to test some sort of a improved urine diverter with this current toilet model that's working well for us? And what you can see in this photo is the cut funnel attached to a toilet seat, and then one of the prototypes made out of fiberglass in country. So we had an initial rotomold made, and we tried, doing vacuum seal molding over it. That plastic wasn't very strong, but we found local artisans that work with fiberglass. And what that's allowed us to do is to create these prototypes and iteratively test different urine diverter models, and also make small adaptations to the mold where we're not eating the cost of a new mold each time. And that's been really important to us, because we've been able to test, you can see it here attached to a toilet seat and kind of a top-down view. So you can see how it overlaps with a bucket. That's allowed us to test it in our offices with our many staff members and many external partners and guests. And that's been really critical to get that feedback even before sending out into the field with our customers, because their satisfaction is why we're on this journey in the first place. And with this improved urine diverter and our current toilet model, we have come across a major constraint, which is kind of height, and something that we have lovingly called the nut ridge problem, which is that the height of the toilet, it's already relatively high for a kind of toilets on the market, in order to accommodate the 5-gallon feces containment container. And what happens when you overlay the urine diverter on that is it ends up not having a lot of distance between the user and the urine diverter, and causes some dissatisfaction. And so enter somebody who I believe is still on the line, Matthew Lippincott. I don't want to say that that's the only problem that we brought to him when we were looking to continue to make improvements after the iterative improvements in country, but it was one of the big questions, is how do we kind of readjust the different containers that are being used within essentially this same toilet mold to get to something that's more user friendly. And that began in 2017, as we were just reminiscing about, but has continued to today. And this latest model, what we've been able to do, we want to move towards injection molding. We would like to at least move to vacuum seal molding and more mass production, what local producers can do. But what we've done in order to test this before that major investment is to use 3D printing that's coming out of Port-au-Prince. So these are expensive pilots, $100 a pop. So we're not solving the price question right now. But what we are testing is kind of comfortability, usability, and durability. And these are currently in our offices. So I got to use one. And as somebody who is a seated peer, you know, I can't really test the nut ridge issue, but I can report back from our staff that there is higher comfort with this new model. And I think what's really important, again, this is the journey that we're on to fit something to our current model. And as we look towards our next steps and how we want to continue to improve, we want to be hitting that customer satisfaction while also moving towards something that's sustainable and is expanding our ability to serve our customers. And so our next steps are wanting to get additional urine diverters out to customers. We'll likely begin with some of our employees who are customers, and then look at some of our smaller service zones, or maybe collaborate with our customers to make it happen. The other is to really push and expand and look at what our local production options are, but also the supply chain. We've had a lot of issues with local production standardization. We've seen that in our feces containers, that batch after batch, they're not always the same. So we're really looking at local production, but we're also open to and exploring what it would look like to produce these elsewhere and bring them in. But one of the things that I didn't mention earlier is we're a service of about 1,500 customers, individual households with a really low price point for our service. And we're hoping to grow to 8,000 over the next 5 years. But one of the realities is that isn't mass production for some of these kind of more global producers. It is somewhat mass production for some of our local producers. And so we're just trying to bridge that gap and find what will be the best fit for this toilet to carry us through for this price point. But some of the big picture thinking that we have at Soil is really looking at what additional ecological sanitation options we can offer that might move our price point or our capacity to increase the cost of the toilet to some of these more kind of all-in-one, highly designed models for some parts of our service. So I think that's all I've got for you today. And questions now or at the end of the panel. Just wanted to share, this is a big portion of our team that has just held strong and offered an amazing service throughout the pandemic and throughout really challenging times in Haiti right now for just movement in general. And they really, really just keep it going. So lots of appreciation for them.
Wonderful. Thank you so much, Jess. That was a great look into really like the nuts and bolts of how to implement a system for a very particular context. And we've been following the work in soil for a long time, and it's great to get an update from you on what's going on, especially these really challenging times in Haiti right now. So next up is Sybrand Metz, and we have a recorded presentation from him. We'll start in a moment. Called Decentralized Wastewater Treatment for a Green Future. And Sybrand is the technical director of DESAH in Netherlands. He obtained his PhD at the University of Twente in 2003 on membrane science. After that, he was senior scientific advisor, program manager at WETSUS, European Center of Excellence of Sustainable Water Technology, until 2016. From 2014 to 2019, he was CTO at Metal Membranes, and since December 2019, he is the technical director of DESAH. So we'll start that now.
Hello, good morning, maybe good afternoon. My name is Sybrand Metz, and I'm the technical director of DESAH. And today I want to tell you about decentralized wastewater treatment for a green future. At DESAH, we see wastewater not as a waste, but we see it as a resource, and we see it as a resource of water, but also a resource for energy and a resource for nutrients, and how we can extract it, those valuable compounds and the energy and the water, I will tell you in the coming presentation. You see here a city, and this city you have a green side and you have a desert side, and we believe that by decentralized wastewater treatment you can create a green local environment, and that's how we want to contribute to a better future. So the take-home messages I want to give is that you can have an effective wastewater treatment if you separate all the wastewater streams at the source, especially when you use vacuum toilets. By using vacuum toilets, you save 30% of water, and you can also add your green waste to the treatment system, and this produces 50% more biogas when you add your green waste. Also, because of the vacuum toilets, you have concentrated your wastewater by flushing less water, so your nutrients are much more concentrated, and this allows for a better recovery of your nutrients. And moreover, because you did not use so much cold water for flushing, your gray water is still at a relatively high temperature, about 30 degrees, or 20 degrees, sorry. And this is a lot of heat, and you can recover that heat by means of a heat pump. And we did some calculations for some situations in the Netherlands, and this is really a significant amount of energy. About 20 to 40% of all the energy need in a house for heating your house can be recovered from your wastewater. The gray water you have obtained after treatment has a very high quality, and this allows you to reuse it for different kind of purposes. And one of the most important things is that by treating your wastewater locally, you don't need a sewer system. So especially when you have a limiting wastewater treatment capacity, or your sewer system is limiting in capacity, you can think about using a decentralized approach, so you can treat your wastewater locally. So by separating your wastewater in different streams, you can treat it more effectively. You know this from your house, where you separate your green waste, your glass, your paper, and all your plastic material. In the Netherlands, we separate them separately, and they are separately brought to the landfill, or they are treated in another manner, so you can recover all your goods from your waste more effectively if you separate them. You can do the same for your wastewater. If you look at a house where you have rainwater, you can use your rainwater just for irrigation, that it goes to your groundwater or to your surface water. You don't have to treat it. But in your house, you have several wastewater streams. You have your gray water from your shower, from your washing machine, and from your dishwasher. And that's you can separate that from your black water, and the black water that's coming from your toilet. And what we promote is, for an effective separation, is to use vacuum toilets, and because you use less water for flushing your toilet, and you keep all your components very much concentrated. So that's very beneficial for further treatment. And moreover, you can add your green waste to the system and to the vacuum system. So also the green waste can be treated in the same installation. And from the black water, we recover fertilizers, energy through digestion, and from the gray water, we can recover clean water because it's lightly polluted, and this allows for reuse, but also we can recover the heat from the gray water. So if you look at the black water, and this has a high level of organic components, and so the concentration is relatively high, there's a COD of 10 grams per liter, and this allows you to digest it. And by digestion, you extract energy out of your wastewater instead of putting a lot of energy in your wastewater through aeration to convert your components into CO2. So by doing digestion, you generate energy. Moreover, since you use vacuum toilets, the concentration of your nutrients is relatively high, so it's very easy to recover your nutrients like phosphorus and also ammonium in the form of fertilizers. And since you treat your black water in a digester, it has a relatively long residence time, you also remove more micropollutants like medicines and hormones. You can remove them more effectively. Since the gray water, it's less polluted, and you need less energy through aeration to treat it. And gray water has, after treatment, a relatively high temperature, and you can use that for a heat pump and to extract the heat and to give the heat back to a district heating system or to your house or a group of houses. And after treatment, it's very suitable for irrigation. So this is the vacuum toilets. You can see here on the left-hand side the picture. And vacuum toilets, they save on the total water use, they save about 30% of all your drinking water. So you have a vacuum pump in your system. This keeps all the tubings to the toilets at a low vacuum of about 0.6 to 0.5 bar. And when you push the button of the vacuum toilet, a valve opens and the wastewater is flushed away with the vacuum, and air and 1 liter of water flush away your waste to the vacuum collection tank. And you see here in the middle and on the right, you see 2 vacuum toilets, and they look similar to normal water flush toilets. The only difference is that they use only 1 liter per flush, whereas a traditional toilet uses 6 to 8 liters per flush. So this saves you on average, and this is calculated for a Netherlands situation, it saves you about 11,000 liters of water per person per year. And maybe you remember them from the airplanes, that they make a lot of noise, but the newest versions of the vacuum toilets, they have similar sound levels compared to traditional toilets, or even lower. So that's, if you look at sound level, and the vacuum toilets you see here on the photo, they have a sound level comparable to normal flushing toilets. And another good advantage of these toilets is that they also remove aerosols from your wastewater. So if you flush the toilets, no aerosols come into your building, but they are flushed away with the vacuum. So that's another advantage of using vacuum toilets, especially in public buildings, compared to traditional toilets. So here you see a graph of two neighborhoods in the Netherlands. And you have here the water consumption on the y-axis, where you have the water consumptions in liter of water per person per day. And the blue bar is the total water use. The red-brown bar is the black water use, and the green bar is the gray water use. So that's on the left-hand side here. You see the average water used in the Netherlands. It's about 120 liters of drinking water per person per day, and about 85 liters of gray water per person per day, and 35 liters of black water per person per day. And that comes to the use of a normal water flush toilet. If you go to vacuum toilets, and we have here two examples in the Netherlands of Noe-Hays, which is a neighborhood of 230 houses where they all have vacuum toilets, kitchen grinders, and a treatment system. And there you see that total water use is lower, and that comes because you use vacuum toilets, and the amount of flush of black water produced is about 12.5 liters per person per day, and the amount of gray water is 85, no, even less, sorry. It's about 70 liters per person per day. And in this neighborhood of Noe-Hays, they have a vacuum toilet, but also a kitchen grinder. And the kitchen grinder also uses some water. So that also goes to the black water. So here you see that in Noe-Hays, the black water is a little bit higher than in Lemmenweg Oost. And Lemmenweg Oost is a project where 32 houses are equipped with a vacuum toilet, but no kitchen grinder. And here you see that you have a lower black water production compared to the Noe-Hays, but both are still much lower compared to the Dutch average. And what we also see, and that was very surprising to us, that also the gray water use the gray water discharge was lower compared to the Dutch average. And that is, we think it's because people are more caring about the environment and using less water, so they also start using less gray water or producing less gray water. So I think the vacuum toilets also stimulates them to save more water. So some numbers from neighborhoods in the Netherlands, all with vacuum toilets. Like I said, in Noe-Hays, this neighborhood of 230 houses, they have next to the vacuum toilet, they also have a kitchen grinder. And here you see on these three photos how that looks. It's just a normal kitchen grinder. I think you're all familiar with these kitchen grinders in the US. You just throw your green waste in, you press a button, and then all your kitchen waste is grinded and flushed away to the sewer. And in this case, we have a vacuum system and a vacuum valve. So the green waste is flushed to the vacuum system, which find people in Noe-Hays very convenient and very easy to use. So here are some examples of some projects or some buildings or neighborhoods where they applied vacuum toilets. So on the top left, you see this office building of Bloomberg in London, which has 4,000 employees. It has only vacuum toilets in the building, and they save a lot of water, and that gives them a very high BREEAM score. So this is the most sustainable office building in London, not only to the vacuum toilets, but also to other measures, but vacuum toilets contribute significantly to the high BREEAM score. In Snake, we have a neighborhood called Noe-Hays, and there are 64 apartments and about 160 houses, and they are all equipped with a vacuum toilet and kitchen grinders. And there's also a central or decentralized treatment system in the neighborhood that treats all the wastewater of these 230 houses and apartments locally. And this is already in operation since 2011. And then there's a neighborhood in Helsingborg called Oceanhamn, which has apartments and offices with vacuum toilets, but also with kitchen grinders. And there they also have a decentralized treatment system to recover also nutrients and fertilizers from the wastewater. And then in the Netherlands, there's the water campus, where a lot of companies work together on new water treatment systems. There they also have vacuum toilets in their building. And there's in Den Haag in the Netherlands, there's a ministry with 6,000 employees, where they also have vacuum toilets. And here you see in the picture the digester for the treatment system. And in Ghent, there's a new neighborhood where they also have 500 apartments, where they also have kitchen grinders and also vacuum toilets in their apartments. And this is a new built environment. So this are a couple of examples of places where vacuum toilets are used, and also the wastewater is treated. There are more. So if you want to know more about these examples, you can send me an email or contact me. So how do we treat the wastewater? So we have the blackwater coming from the vacuum toilets and the kitchen grinders, and we have a digester operating at 35 degrees, where we convert the organic components without oxygen into biogas, and we remove about 80 to 90% of all the organics present in the wastewater, and we produce about, on average, 12 cubic meters of biogas per person per year. That's enough to cook your dinner on, but it's relatively a low amount of all the energy you use for heating your house. But if you compare to wastewater treatment, normally you would need energy to convert your organics into CO2, but now you extract biogas out of your waste and do something useful with it. Also, sludge is produced, and the amount of sludge that is produced anaerobically is about 2 times lower when you compare it to a conventional wastewater treatment system. And also the quality of the sludge is much better, and because you don't have industry bringing heavy metals into the sludge, or rainfall from your pavement with some heavy metals that could contaminate the sludge. So the sludge we produce is relatively clean, and you could reuse that for your soil, and to get a better soil with the sludge from this decentralized wastewater treatment plant. So after the digestion, we remove the ammonium, and we use here Anamox bacteria in an Holland reactor. And with this bacteria, we convert the ammonium into nitrogen. And this process uses a very relatively low amount of energy to convert the ammonium into nitrogen. So after ammonium removal, we can recover the struvite very easily, and we just add some magnesium chloride, and we can recover phosphate in the form of struvite. And that by doing so, we can recover about 80% of all our phosphate. And this struvite, that's a fertilizer, and the amount of struvite we can recover is about 20% of all the phosphorus needed for a person to grow the crops on. So this amount of phosphorus you can recover from your wastewater is significant. So after the USB, the Holland, and the struvite precipitation, we bring the water to the grey water treatment to give the final polishing. So we add the treated black water with the grey water, and then we have an activated sludge system, a very conventional step where we convert about 80 to 90% of all the pollutants. And after treatment in this activated sludge system, it's still about 20 degrees Celsius, and it's a very relatively high temperature, and you can extract the heat for heating your houses, and you can do that with a heat pump. And as a last final step, we are now using a nanofiltration system to remove or to retain all your micropollutants, like your pharmaceuticals, all your drugs, all your medicines, all your hormones, but also bacteria and viruses. It only only water and salts go through the nanofiltration membrane, so you have very clean type of water. And the components that are retained, and they go back to the activated sludge treatment, where they eventually are converted into CO2. So this is how we do that in Snake for a neighborhood of 230 houses. You can see here the treatment house, and this treatment house is divided in two parts. You see here on the right hand side, you see this is the wastewater treatment, and you see here this blue containerized system. That's our activated sludge system. And on the back we have the digester, we have a Struvite precipitator or Oland, and here on the left side of this building there's the heating system with heating pumps and also the district heating system. So this building is divided in two parts. So on the right hand side wastewater treatment, and on the left hand side the energy part of the neighborhood. So we have a very high removal efficiency. Here you see on the right hand side, you see some Struvite that we recover from our wastewater, and we remove 90%, 95% of our COD, 90% of our nitrogen, phosphorus we remove and recover about 80%, and also our suspended solids. So it's a very effective way of treating your wastewater. And also with a nanofiltration unit we use. You see here a skid for an installation of 280 cubes an hour. You see a nanofiltration skid in the front of the picture. On the back you see two digesters of 50 cubes, and you see here in the table some units for the wastewater quality. So we have the influent, and that's the influent of the gray water, and after our activated sludge system, that's effluent without nanofiltration. You can see that we have removed already quite some organics, but also nitrogen and phosphorus. But after the nanofiltration, we really have a high wastewater quality. The COD is very low, but also the nitrogen and the phosphorus, and these numbers are very low, below 0.5 milligrams per liter, and we could not detect any bacteria present in the permeate of the membrane. So we have very clean water, and this allows for reuse for different kind of purposes, for example irrigation or using for your washing machine, dishwasher. So by treating your wastewater locally, and when you separate them at the source, you can recover very clean wastewater. So this is the question I always get, is about how about the cost. So we did some calculations, and this system becomes more economic attractive when you have a larger system. So these are made a lot of assumptions for these calculations, but this is for a situation in the Netherlands. And these costs, they include investment cost, and also the investment cost you have to do at your home, and by adding a vacuum toilet, kitchen grinders, but also some extra tubing in your house. It also contains the investment in the total investment in a vacuum sewer system and a grey water sewer system, and also the investment for your installation and your facility, and contains the depreciation, the maintenance and the management of the installation, and also the cost of consumables and electricity. So everything is included in the cost. And in the Netherlands, we have to pay taxes for the wastewater treatment. It's about 60 euros per person, and also for the sewer we have to pay taxes. So it's about in total 120 euro per person you have to pay to treat your wastewater, and that's comparable to an installation of about 750 persons. But this all depends on the local situation. If you, I can imagine that in the US the numbers are a little bit different compared to the Netherlands, and also it depends on if your sewer capacity is limiting or your treatment capacity of your wastewater treatment plant is limiting, then this also has an effect on the comparison of those costs to these type of costs. But you can take away from this figure that for it's economically feasible to treat it decentralized when you treat it for a neighborhood for more than 500 people. So here are some references we have built as DESAH. And we started in 2005 with our installation for 32 houses in Lemmeweg Oost. You can see here the left-hand side picture, the treatment installation in the garage of one of the houses. And we built some other installations also abroad. You see the installation in 2011 in Noorderhoek, where we treat wastewater of 230 houses, and this installation is still operational, and we keep it operational, so we learn still a lot of them. We also, you see here with the crane, you see here this small black vessel, and that's the digester being craned into the building. And we of course Oceanhamnen in Helsingborg, Sweden, but we also have our floating wastewater treatment plant for a project in Buiksloterham in Amsterdam. And yeah, the take-home message, we're back at the beginning. You can treat your wastewater effectively and recover your energy, nutrients, and water by separating them at the source and treating them locally. You can save 30% of your water with vacuum toilets and green waste adding to the system. You can produce more biogas, and you can recover your nutrients quite easily. And since you don't flush away a lot of cold water and mix it with the grey water is still relatively warm, so you can extract a lot of heat out of that. And the grey water has after treatment a very high quality, and this allows reuse, and you don't need a sewer system. So these are the take-home messages I want to give. If you have more questions, please contact me, and you can send me an email to s.metz@desah.nl, and thank you for your attention.
Our next presenter is Kim Nace, and she's presenting innovative technologies for capturing nutrients from source-separated urine or blackwater. And Kim is the co-founder of Rich Earth Institute and CEO of Rich Earth Tools, LLC. Creating circular water and nutrient cycles from human sanitary waste should be low-hanging fruit as we humans attempt to live within the boundaries of our ecosphere. At Rich Earth, we recognize the need for new efficient methods that capture and process high-strength wastewater to better manage our precious critical resources. In this presentation, Rich Earth Institute announces a new spin-off, Rich Earth Tools, LLC, and the products that we are bringing to market.
Okay, well, I just first want to say how much fun it is for me to present at a conference that started upstairs in my living room in 2015. So it's pretty exciting to see the evolution of that first group of 15 people that came together in 2015, and now here we are on many continents and many countries. And I'm always inspired by the passionate group of people that gather for this event, and also just to let you know, having been at all of these for the last 7 years, I am able to witness the many, many collaborations that have come out of this event. So be hopeful and heartfelt that this event is an opportunity for more relationship building and collaborations. So Rich Earth Tools is a spin-off company that started because over the last 10 years, we've had a research and demonstration institute with the Urine Nutrient Reclamation Project, our local community scale project, which has allowed us a place at a space to iteratively develop many of the tools and things that we need to build the infrastructure for urine nutrient recovery. To change directions. Yeah. So I've got this thing in the middle of it. It's bothering me. Okay. So what I want to announce today is just some of our products. We've been doing a lot of things over the years, and these are 4 different things that we're going to talk about today that we're like ready to say to you, yes, we're ready to bring these to you to share. There's a few other things, but we're not going to be discussing those for a little bit longer. They just need a little more time. So with urine nutrient recovery, we have collection, transport, treatment, and application. And our informal urine collection with cubies and funnels is something we've been using for many, many years. People have often asked us if we would sell it and ship it, and we haven't done that in the past, but we're ready to do that. So these are the 4 different things I'm going to talk about: the Cubian funnel, the truck pump system, our pasteurizer, and our building scale freeze concentration system. So before I dive into those things, I have this kind of enthusiasm for technology readiness levels. It's a concept. The 9 levels of technology readiness that you see here are from the Department of Defense. They don't exactly fit our particular context, but it's a good beginning for us to start to say, you know, when you are developing an innovation to bring into the water sector, you know, where are you in the process of this? Where are you still at just an idea stage? Have you moved to the proof of concept? Have you put it together in a lab? Do you have a prototype? Have you iterated beyond the first prototype? And then, you know, you keep moving up the scale. Is it actually in a relevant environment? Is it out there where other people are going to start to look at it? Is it available for beta testing? So I would like all of us to I'd like to encourage us as we bring in new innovations to start to use some kind of a scale like this so that we can communicate with each other well. It's good to communicate with other researchers, funders, investors. And so we've been using this, and this helps us to know what's our next step, which next step do we need to take in our particular technology. So back to the 4 things I wanted to share with you today. The 5-gallon collection system is something that we haven't shipped in the past. It's been really effective here in Vermont and for our regional community that collects for our demonstration project. You know, we can provide these easily. People come and pick them up. But now, if you would like to have one of these, either for your own use, or if you are a researcher and want to stop using synthetic urine and actually collect with your staff members, you know, it's always been interesting to me to listen to researchers say, yes, well, we use this synthetic urine. I'm thinking, but you got all these people there, you can just get their urine. So if you're interested in this, please email me at Kim at Rich Earth Institute, and we will put you on the list and be able to send you one of these. Now, our truck pump system, this is not something we're going to put in a box and send out to you, but this is something we've had a lot of experience with. Early on, we used a septic truck to haul our urine, and they had to clean out a special tank and make a lot of special, differences for us. And we ended up eventually having our own truck where we were able to create our own pumping system. Liquid urine alone is quite a bit different in texture and consistency from septage. So you don't need to use the same sort of systems. We can consult with you and help you set up your own truck if this is a place that you need, that you eventually want to go. I love this picture because it shows the pipe coming out and Arthur just hooking it up into the house where one of our urine donors has a tank right in the basement. It's a very efficient method for picking up urine and transporting it. So let us know if you want to do this and you need our help. The third thing on the list is our pasteurizer. Since 2019, the summit that was held in University of Michigan, we had several people raise their hand and said, well, is that for sale? And at the time it wasn't, and now it is. So I'm happy to say that we already have 3 customers who are expecting to buy a pasteurizer from us in 2022. And if you are in the need of one, if you have a community collection system or any kind of urinal going in that's going to have a tank to collect, let us know. We are building these. 25 gallons a day is roughly 10,000 gallons a year, and it's about the average. It's about the amount of urine that you would collect from 100 people. So this gives you a sense of what this would be for. Time and temperature. One thing I'm very happy about our first 3 customers, they are in 3 states, not in Vermont. One is Michigan, one is New York State, and one is Massachusetts. So it's kind of exciting to see if the technology or the possibility of urine treatment is out in these other states. It's going to push regulation as well. And our final system, which we're also very excited about, is our building scale concentration system. And it's everything inside the gray box there is what is part of the system. You know, the toilets and everything, how the collection comes in, and the other gray water is not part of it. But we are developing freeze concentration, and the pasteurizer goes along with this for a building scale system. You'll see a little person in there with a control that doesn't actually go inside the box. I don't want to mislead you that there needs to be a person on site with a computer to control this new system. That's going to be a remote control system, which we will be able to handle from Rich Earth here. So you'll learn more about this system. The exciting thing about that is that we intend to do some beta testing on this in 2023. It'll be ready by then. And we already have 2 sites ready for some beta testing, but if anybody here in this call would like to, you know, talk to us about being an additional site where we could take this freeze concentration system and use it for beta testing, please let us know. I do want to point out that like Sybrand's talk in the last video, we are not just looking at urine for this freeze concentration, we're also looking at the effluent from the anaerobic digester from high strength source separated black water with the vacuum flush toilets. So we're moving along with this technology. This is just a timeline of how we got started. We have a couple patents, and in 2020, we received our first funding from the National Science Foundation from the SBIR program, which is called the Small Business Innovative Research Program. We're winding down that grant and hopefully going to be selected again for the phase 2 in 2022, which will help us get this freeze concentration system to the beta testing by the end of 2023. You can see down here, the cost of the system is very much an estimated cost, $67,000 for the freeze concentration system. We will know much more about that by the time we're ready for the beta testing. We are currently seeking investment funds. We're doing some pitches regularly now with different people. And so if you would like us to pitch to you, great. If you know someone you think who would be interested in investing in this new technology, please feel free to send their information to me or connect us. And the last thing I wanted to say today was that I really get excited about this summit. And I also just get excited about the idea of getting pilot projects out in the world. As Lynn was saying this morning, and others have, and Jay Garland was saying, you know, we've got to see it. And I believe that very strongly. I was at the GIZ webinar in the early spring this year, 2021, where they were releasing a report called Sanitation, the Underutilized Driver to Achieve Urban Climate Resilience. I couldn't agree more with this comment by John Matthews. He says we need to stop having one tool per organization. And what that says to me is that if one team has a wonderfully working anaerobic digester and another one a freeze concentrator and another one a really great urine diverting toilet, that we need to begin to put these tools all together. Abe and I had the good fortune to have been funded by the I-Corps program through the National Science Foundation to interview stakeholders all across the landscape of this emerging field of nutrient recovery. And there are many civil engineers that work for large organizations, you know, that design the Google campus and other things and places like that. And they say we need the whole package put together. We don't want to be the ones, the building owners and the architects don't want to be the ones to say, here, use this vacuum toilet, put it together with this system. You know, the fertilizer will be distributed that way. They want us to package that. So that says to me that we sort of need to be representing each other as we develop our new innovations. That the Lauf and Save toilet, you know, from Europe, it's having a hard time getting over here, but it needs people like us who are here to receive it and to integrate it and to work that, you know, these different fixtures with our treatment technologies. And similarly, other things, you know, we need to be able to go back and forth with each other. So that's my final comment, is that, you know, we need to see all these puzzle pieces coming together and have the innovations find each other and become full treatment trains. So thank you very much. That's all I have to share. Oh, just one more thing. The main takeaway is we have pasteurizers for sale if you want one. So please let us know that if that comes up for you. Thank you.
All right, thank you so much, Kim. We've got 2 more presenters. The next one up is Kevin Orner, who will be presenting opportunities and challenges of installing a urine diverting toilet at the University of California, Berkeley. Dr. Kevin Orner joined the faculty of the Department of Civil and Environmental Engineering at West Virginia after working for 2 years as a postdoctoral researcher in environmental engineering at the University of California, Berkeley. Dr. Orner served for 2 years as a Peace Corps volunteer in Panama and was awarded a Fulbright research grant in 2018. So I think we see your screen, Kevin, and the floor is yours.
Thank you for the introduction. And this actually continues well off of Kim's presentation because it's talking about the installation of a Laufen safe toilet at the University of California, Berkeley. So I'll give you a little bit more of the history of how that came to be. First, a little bit of background. My work with toilets and urine diversion started over 10 years ago. I was a Peace Corps volunteer in Panama as part of the Master's International Program at the University of South Florida. So part of my work was writing my thesis on inline chlorination, but another part of my work was constructing latrines. So I was in an indigenous community in Panama. You can see the toilets that were traditionally used on the left, and then on the right, there are also other toilets that when governments had money, they would install these other toilets. So you can see in these pit latrines, just simple, one hole going down to a pit. And then additional part of our work was building composting latrines. So you can see there are 2 different seats. You would go up to there. And then you can see that there's the urine diversion. So the urine is collected in the front, and then the feces are collected in the back. Please excuse me, my son is crying. And then in my postdoc recently at the University of California, Berkeley in 2019, we had work with Sanergy. So you can see here, Sanergy's Fresh Life toilet. So it's kind of similar effort of urine is collected as well as the feces. And then following the conference here with Rich Earth in 2019, we were looking at installing a pilot urine diverting toilet on the UC Berkeley campus. So here's just a picture of the Laufen toilet on right when it's installed, and on left, it's the basic idea of that the urine is separated with the urine trap, and then the feces and flush water go down differently. So the installation process, it started back in November 2019. I believe this is the last time we all got together. And during this process, I was able to make contact with the representative from Laufen. And after that, we got many boxes at the University of California, Berkeley, with some of the different Laufen safe toilet components. So that was about 8 months later. And then eventually, almost 10 months after that, partially due to the pandemic, partially due to bureaucracy of working on a university campus, the toilet installation was finally approved. And then just a couple months ago, we are finally working on the actual design for professional installation, because we found out that this is not a simple process and facilities needs to be involved, and there's lots of things that go along with that. But the basic idea is that the source separating toilet will be on the 4th floor. There'll be a urine storage container on the 3rd floor. There'll be a ventilation pipe, and that we can use this urine for research. So instead of just collecting urine in individual containers, or perhaps a plug for Rich Earth Tools using one of their 5-gallon containers, our idea was we'd actually have the source separating toilet so we could collect urine from many more people than we would just with individual containers. So you can see that the toilet installation is finally set for spring 2022, but this is a very long timeline, much longer timeline than I anticipated. I expected this would be up to a 1-year process, and you can see it'll be about 2.5 years. So just looking at some of the challenges and opportunities, I feel like there are 2 main challenges. One is lack of existing regulations, and 2 is just the complexity and cost of retrofitting. So this is a paraphrase of one of the comments we got from our facilities. So again, this is on our research campus, but facilities said, oh, if there aren't any standards, we can't install this. So we had to persuade them, saying this is a research project. This has been installed in other places, but the lack of existing regulations was a barrier that caused some delays. And other complexities and costs, there are lots of pipelines involved when you're talking about urine storage container and going from one level of a building to another. Another issue was handicapped access and making sure there's enough room for people with handicap to have access to the toilets, and then also just maintaining service in the bathroom for both men and women. And then additional costs were much larger than anticipated, including the design, the installation, and then the actual cost of the toilet. So just to give you a breakdown of what it cost for us, this was way much higher than I thought it ever would be. And again, this is the caveat of installing it in the university campus and also the state of California, which just has higher numbers. But this is what it cost us. So 30,000 general construction, other costs for inspections, physical plant trades, architect, all the way down to code compliance and contingency. So $52,000. So I share this with you saying this is how much it cost us. And I hope that with this community of people here, I hope that going through this process, we can make a way for that number to go down, whether it's just less because you're not in California or less because you're not on a university campus. So a few opportunities I see from this. One is just firming up regulations on this so you don't have feedback from facilities. So again, I point you to the talk on Thursday about the work of the Gold Ribbon Commission. And at least for us, a lot of these costs were due with retrofitting a very old university building. So if there's a way that we can, have these different pilot examples so that we have the designs and regulations in place so this can be installed during new construction. So this isn't a happy story by all means, but I point this to say, here are some of the challenges we've had, and I hope that as a community, we can overcome these challenges in the future so that we see more urine diverting toilets and we can do it at a cost that's much more reasonable than $52,000. So with that, I thank you for your attention.
Great. Well, thank you, Kevin, for the presentation and for sharing that truly terrifying number with us. That's remarkable. And I certainly hope that your effort and expense in blazing that trail helps to make the path easier for other folks that come behind. So thank you for that. Our next presenter and our final presenter today is Ole Ersson. The title of the presentation is Urine Diversion and Utilization in a Populous Urban Setting. A retired family physician, Ole Ersson is the co-founder of Kailash Eco Village, a sustainably focused intentional community. He has an ongoing interest in ecological sanitation and published the Kailash Eco Village project in the journal Blue-Green Systems. So Ole, it's yours.
All right, so thank you everyone. My name's Ole Ersson and I'm a co-founder of Kailash Eco Village. We've been doing a project since about 2014 where we've been doing community-wide urine diversion and use on our extensive gardens on a fairly populated urban setting. So over the past several years, since 2014, we've recycled about 6,000 gallons of urine, and currently we're doing about 1,200 gallons a year. That's about 4,500 liters per year. So let me give you some background. Kailash Eco Village is an intentional community located in Portland, Oregon. We're about 4 miles from the city center. In this photograph here, you can see the city center in the distance. Our total grounds area is 1.75 acres. About 70% of that is gardens. You can see we have a big parking lot here, and then the buildings take up a significant amount of space. Altogether, we have 34 living units and 55 residents. The garden space is about evenly divided between 4 different types of use. We have 41 individual garden plots that are modeled after a community garden program where each gardener makes the decisions and manages their own garden plot. Additionally, we have communally gardened annual vegetable areas and a communally gardened fruit trees, berries, and grapes area. And finally, the last quarter of our site is ornamental gardens, rain gardens, and wildlife gardens. So how do we collect our urine in our community? Well, we have one outdoor shelter with a wall-mounted urinal that it goes directly into a urine tank. But for the most part, residents collect urine in their own units in containers such as bottles or pots. And then they deposit it into our urine storage tanks just by pouring it in. Then we sequester the urine for 6 months, which results in a high pH, usually about 9.5, which essentially makes the urine pathogen free. Aged urine can be used in any garden areas due to its high quality nature. So urine recycling, about 30% of our residents participate in recycling some or all of their urine. It's somewhat seasonal in nature. So during the growing season, which is spring, summer, and fall, we have more participants. But essentially we divert about 1,200 gallons per year from the usual sewage system. 6,000 gallons since 2014. Approximately 20% of the flow goes into 2 of our composting projects. This picture here is of our kitchen compost area and where we compost kitchen material as well as chopped garden refuse. And the urine allows us to supplement that with nitrogen, which results in better composting. Urine storage. We have 5 on-site 1,000 liter IBC tanks. You can see here that the first one is empty, but the ones in the background are essentially full. We fill them to about 90% to give a little bit of room for expansion if we have freeze issues. In Oregon, we're a fairly mild temperate climate, but we can get hard freezes for a week or 2 where freezing would become an issue. It takes us about 2.5 months to fill one of these 1,000 liter tanks. We also have a 55 gallon tank. Let's see if I can point that out here. You can see that here. And as I mentioned, urine is sequestered for 6 months. So how do we distribute the urine? We distribute undiluted urine several times during the growing season by pumping it using a sump pump and regular garden hoses to the growing plants. This is followed by an immediate washing of the foliage with fresh water, which prevents any lingering odors. It's essential to get any nitrogen containing material that has ammonia and an ammonia-like odor cleansed off of the foliage. Ideally, you'll distribute as close to the ground as you can to avoid any splash on the foliage, but some will be inevitable. The fresh water also dilutes the nutrients. So here's a little video, a 30-second video, which just gives it. Okay. Oops. Okay, so what are the legalities of this? So interestingly, our Kailash project has been fully permitted by the city of Portland, Oregon. Portland has adopted the building codes based on WESTAN, the 2017 plumbing code, water efficiency and sanitation standard. It's an ANSI standard that any jurisdiction in the country or world for that matter can use. It includes guidelines for human excreta collection, processing, and use. This is an illustration of a schematic that was taken from our city permit. So in summary, urine recycling in a dense urban setting can work. It saves water and otherwise wasted nutrients. It's safe and it's becoming socially acceptable, or maybe I should say more socially acceptable. It's still an area of squeamishness among the general public. The plants, of course, love it, and it can even be legal, and it's definitely fun. So thanks for your attention. For more information, you can check out our website. There was also a recent video on YouTube that describes our project in a lot more detail. Thanks, everyone.
Wonderful. Thank you so much. So that brings us to the end of the presentations. We have about 10 minutes left before 2 o'clock, so we have time for some questions. We had one come in for Julien from Kai. Question was, could you please explain why there is not waste? The ratio of nutrients in urine most probably does not fit the ratio of nutrients in the lactobacilli. And Julien, are you there? Are you able to answer that question? Julien may not be with us. If you're there trying to come along back on, just speak up when you're here. But I'll go to the next question for a different presenter in just a moment. Technical glitch here. And here we are. This one's for Jess from Prithvi, which is similar to the progress soil has made with the diverter designs. Are there any promising options that you are or have been testing for treating the urine that is currently discarded?
Yeah, that is one of the things on the docket for our research team to explore for a number of motivations. Obviously, its benefits for reuse and agriculture, but also to continue to make our toilets more user-friendly, because container-based toilets involve a number of moving parts. But some of the constraints with that, one, in terms of just streamlining where that is dumped, we found that some of even our very decentralized model, but some of our centralized services where we're trying to, serve a more public toilet or other things in the past, there's a lot of challenges with being able to truly maintain those centralized drop-off points, both through, proper usage of individuals, but also kind of security and accessibility of those when they're within the community. For our vehicles, we use, I don't know if you remember from the presentation, but we use these 3-wheeler motos in most of our, it's actually a 4-wheeler motor in most of our communities, because we aren't able to access them with trucks. And then there are other areas where we aren't even able to access with those, and there's a lot of on foot. And so one of the challenges with collecting urine is going to be the heaviness and having proper storage and containers to move it in. So we would like to capitalize on a lot of the progress that's been made with kind of carbon filters in the future, but we're not exactly sure how that will factor in at a household level or at some of our larger scale clients.
Great, thank you. The next question is for Kim, and the question is from Kai. How many people is the system designed for? Oh, and also from Michael Reichman. They both had the same, or Michelle Reichman, both had the same question.
And I guess you're assuming the pasteurizer is designed for about 10,000 gallons a year, about 25 gallons a day, and that would be about the urine from about 100 people. The freeze concentrate system at the building scale, we are starting with 30 and up, 30 people and more in a building scale. Abe, maybe you want to make a correction on that? Because Abe's going to be presenting more on the freeze concentrate tomorrow.
Sure, yeah, and I'll be presenting more on the mechanics of it. But in terms of that system, where 30 or more is the market we're looking at, but that system can actually handle up over 200 people urine only. And that's probably a conservative figure, but because we haven't done the next generation of design on it and actually built a prototype at full scale, we don't really have a precise number pinned onto that. Okay, another question. Let's see. We have questions over here. I've got them in 2 places. Sorry. We had a question for Ole, and I think I had one for Kevin as well. Sorry, I'm a little disorganized with. Here's a question for Ole. Did you consider drip fertigation?
So we didn't really. I mean, we do drip irrigation here on the property, but the problem with urine is the struvite formation that tends to block any small orifices. So I think that would potentially be problematic. In our first urinal setup, we used a smaller diameter pipe using supply piping, and we noticed that we got extreme struvite buildup to the amount that it would actually block the pipes. So we eventually had to change over to 2-inch diameter pipes. Now, my understanding is if you use tubing without the joints that are typical in most plumbing applications, you can avoid that. But we were concerned that struvite would cause problems with drip irrigation.
Thank you. We should actually have a conversation, or we should send you our report when we finish it. We just did a trial this summer on drip irrigation and found some ways that it worked quite well. And I know Kai was involved with the drip irrigation trial in the past as well. So we should put our heads together on that. I think it is a viable option if done right. I just had a comment here from Richard's staff to point out, I overlooked something in my answer about the pasteurizer. The number about 100 people is if you are pasteurizing raw urine. If it's concentrated urine, then that number would go up by the factor that the urine was concentrated. So it would be several times more, depending on how concentrated the urine was. So that was an addendum to my previous answer on that. Oh, I see an Renaud is piping up as well that that if you have soft water or the urine is diluted, then drip irrigation is a good option as well. So let's see. Is Julien, are you back? Are you here now? We had some questions for you. No, okay. All right. So then, what else do we? Okay, I think there's some questions for Julien, but those are the rest of those. I see a couple other questions. Was that a water right hose, Ole, that you were using?
No, I don't believe so. It was a regular 50-foot, 3/4-inch diameter garden hose that we got at Home Depot. So nothing particular about it.
And then another one for you, a lot of questions about your fertilization. When you use urine fertilizer on the flowers where it looked like primarily as a foliar spray, have you seen significant plant response? How does it affect bloom, for example?
No, since the urine is immediately washed off the foliage with the rinse immediately afterward, there's really no significant effect on growth of the plant from the foliar application. We do our best to apply the urine at ground level, but sometimes if the plants are taller, it's impossible to avoid that.
Mm-hmm. Okay, great. And I see also some questions for Kevin that may have been answered in line. Correct me if any of them have. But one of them is the lack of regulations a barrier or a pathway, a challenge or an opportunity?
Yeah, I think it's both. It's a barrier that it can make the installation difficult if you need to point to something saying, hey, here's the regulation we're going to follow. But it's also an opportunity because this community can write the regulations, and that's what the Gold Ribbon Commission and others are doing. Great.
And there was a question for you as well as what the cost of the Laufen toilet itself was.
I know Laufen is very prevalent in the European market, and they're trying to get into the United States market. So perhaps my European colleagues could say what it is in Europe, because for us, it was donated and then there were transportation costs overseas, and that's not viable, at that scale, but perhaps they'll enter the US market in the future.
Okay, thank you. Well, I'm scanning through these comments. I don't think I've missed anybody's questions. If I have, I guess I apologize. I'm reading everything I've seen, so hopefully I got you all.
This is Kim.
Yes, Kim.
Kai was asking me if there is if the stakeholder
analysis that we did through the I-Corps program is available anywhere, or we're publishing it. So I would like to comment on that, we did an interview over 150 people. It was a fascinating process. Bradley Kennedy, who used to work with us at the Rich Earth Institute, was part of that team. The three of us were very intensely working on that for a long time. We're looking for funding to put it all together, to collate it and publish it. I hope we can find the funding to do that before the information becomes, too old to do that. But it was last winter, November and December of 2020. And yeah, we would really appreciate the opportunity to share what we learned, because I think it would be very helpful for people. But we do literally not have the resources at this point in time to analyze all those interviews. So thank you for the question. Hopefully we'll get to do it.